Good everyone, my name is Graphics. In this video, we want to solve a problem involving crank effort diagram. And the question goes like this. It says, the crank effort diagram of an engine is as shown in the figure. Study the diagram properly and determine the value of the moment of inertia of the flywheel of the engine and its mass to sustain a spindle speed of 4,200 revolutions per minute at a coefficient of fluctuation of speed of 2%. Diameter of the flywheel is 400 millimeter. Now, first of all, this is the diagram we are told to analyze. Before we proceed, we need to write out the parameters that have been given in the question. And one of the parameters that is given is the spindle speed, which is represented using the symbol N. So let me write data given. So the first thing we have here is the spindle speed, which is given as what? As N, and that is 4,200. Right? Now the next thing that's given here is the fluctuation of speed, which is given as 2%. So we represent using what? Alpha equals to what? Equals to 2%. And we know 2% is 2 over 100, and 2 over 100 is giving us what? 0.02. That's the equivalent of what? 2%. Now the next thing that was given here is we are told the diameter of the flywheel, D, is given to be 400 millimeter. Now we have to convert it to meter, whereby dividing it by 1000, and that'll give us what? 0.4 meters. And we are told to look for the moment of inertia, I, of the flywheel, and we're told to look for what? For the mass of the flywheel. So these are the two things that we're told to look for, right? Now, we'll start. Recall. We know that our moment of inertia, I, is given as what? The fluctuation of energy all over what? Alpha, that is fluctuation of what? Of speed, multiplied by what? The angular speed square, or call it the angular velocity. Is that okay now? So this is what we have here. I'll call it equation 1. Now we know if we want to calculate for our moment of inertia, we need to get the fluctuation of energy, right? Then we already have our alpha. Then for omega square, let's do that briefly. We know that for angular velocity, recall the angular velocity, this is given as what? 2 pi n all over what? Over 60, right? Now we move forward. If you input your value here, we'll be having 2 pi means what? 22 all over what? Over 7, right? Multiplied by the number as in the revolution per minute, which is 4,200. Then we have the 60 still remaining here, times 60, right? Now if you input your value here, you're going to be having 2 times 22 multiplied by 4,200, and that is divided by 7 times 60, and all this value is going to give me 439.82 rad per what? Per seconds. That is what is our what? Angular velocity. Is that okay? So calculated for our angular velocity here. Now we know the fraction of speed, which is given as 0.2. Now what is just remaining here is for us to calculate our fluctuation of what? Of energy, right? And we should know that the fluctuation of energy is the area above the mean torque line. Are you with me now? This is what? The area above the mean torque line. If you come here, the mean torque line can be anywhere around from this point. We are given that from here in the diagram. Here is given as, let me draw that out. It's given us from this point. Say this point from the diagram is giving us 1620. 1620. So the mean torque line is always in between 0, right, to what? 1620 of the torque that we have there. So it will be somewhere around there. So wherever the mean torque line is, the area above the mean torque line will give us what? Our fluctuation of what? Of energy. So the first thing we have to do is calculate for what? Or for the mean torque line. Is that okay now? So let's do that and see how it goes. Now, recall. Let's move forward. Now recall, we know very well that our total area, right, is giving us the mean torque multiplied by the crank angle. I'll just call this my equation what? Equation 2. The area, the total area is given as what? The mean torque times what? The crank angle, right? Now we need to look for the total area, and we need to have the crank angle, which we already have, multiplied by what? The mean torque. Now the total area of what? Total area of this shape that is formed on this diagram here. And this looks like a trapezium, right? Or you can say it is a combination of what? Of plane shapes. What are the plane shape? The shape of a triangle plus the shape of a rectangle plus the shape of another triangle. That will give us the total area of this figure here, right? So let's see. I'll put it this way. So let me put it this way. I'll say that but my total area will give me the area of a triangle, right? Is given as what? Half base times height. So what is the base here? Let's check for our diagram here. This is the base, and that is what? 90 degree, and this is the height, which is 1620. So it will be 90 times 1620. So if I put it there, I'll be having 90 half into 90. Since it's given in degree, your crank angle is always a radian, so you're going to multiply it by what? By pi over 180 to balance things up, right? So half base times what? Times height. So multiply by the height, which is what? 1620. I hope you're getting what I'm doing. That's the area of the triangle plus the area of what? Of the rectangle. The area of what? the rectangle. This is the rectangle. Let's call this is the area of the triangle plus the area of the rectangle plus the area of the other triangle. So we say that my A total, right, is giving us A1 plus what? A2 plus A3. That's what I'm just doing. So I've gotten my A1, which is what I placed here. Then A2 is that of the rectangle, so it is the length times the height. So what is the length here? The length here is giving us what? 90 minus, that is 9 in between 90 and 210. And when you subtract 90 from 210, you'll be having 120, right? So it will be plus 120 times the height. What is the height? The height from here to here is given to be what? 620. So multiply by the height. So we have in bracket 120 degree, but because in degree you need to convert to radian, multiply by what? Pi over what? 180, right? Plus, that is multiplied by the height, which is 1620. That is for the area of what? A rectangle. The length times the breadth, or you say the width times the height. Now plus the area of the other triangle, that is A3, right? So that is the distance from here to here, 360 minus 210 will give us 150, right? So that is half into bracket the base of the triangle 150 degree, convert it to radian. That means you need to multiply by what? Pi over what? 180. Is that taken? Multiply by the height, which is still constant, that is 1620, right? So this is what we have here. Now if we move forward, we are going to discover that if you multiply 90 times 1620 divided by what? By 180, you are going to be having this to be, let's see, 90 times 1620 divided by 180, and let's say 90 times 1620 divided by what? 2 times 180, that is 360. We're going to be having 405 pi. 405 pi, right? If you multiply this, that's what you'll be having. Plus, now, if you multiply 120 times 1620 divided by 180, you're going to be having 1080 pi. Plus, now if you multiply 150 times 1620 divided by 2 times 180, which is 360, divided by 360, you're going to be having what? 675 pi. So put it there, 675 pi. You can see that? Now, when you add everything together, since they're all like terms, they're all having pi, you add 405 plus 1080 plus 675, and that'll give us what? 2160 pi. That is the area, the A total, right? I can call it to be the A total that we have there, right? Now, since we are working in meter, I can just put in meter square. Now, remember in equation 1, right? Since substituting into equation 1, so let's substitute that into equation 1. So substitute, right? Substitute a total area equals to what? 2160 pi into equation 2 here. So we'll be having this to be my A total here. We have this to be A total is equals to the T mean multiplied by the crank angle. So what is the A total? The A total is giving us 2160, 2160, right? 2160 pi equals to the T mean multiplied by the crank angle. Now, what is the crank angle we have here? That is the total angle we have, which is what? 360. So multiply by what? By 300 and what? 360. 360. Right? Now it's in degree, you have to convert it to radian. So that will be pi over what? 180. Now with what we have here, right? With what we have here, I can easily say that with what I have here, I can easily say that um two I can easily put it this way that 180 here. Let me just round it up here at this point here. I can move forward here and say that the 2160 pi equals to the T mean multiplied by 180 in 360 will give us 2 times pi will be what? 2 pi, right? And this pi, we equate this pi, we left with 2. So we will now say that my T mean here will come here. We will now say that the T mean will now be equals to 2160 all over what? 2. And the T mean will now give us what? 2160 divided by 2, and that will give us 1080. 1080 Newton meter. So this is our what? Our main torque, right? So it means that at this point here, this point here, let me rule a line at that point. At this point here, my main torque will be somewhere around here. So I'll draw my line at this point here. Let's say at this point. So I'll draw a line. So this point here is my main torque, and that is 1080. So that is what? The T mean. Is that taken? So if I like, I'll shade up this point here just to give us a better view of it. This is what we're actually the area of the shaded portion. So that area of the shaded portion, this area you see here, is the area of the shaded part is equals to what? My fluctuation of what? Of energy. Are we together? Now we'll start. You see that as this rises, what happens? It varies. The crank angle varies. Is that taken? You cannot compare from here to here to here to here. Similarly, you cannot compare the distance from here to here to the point from here to here. Are we good now? So that is why we are going to calculate the distance between here to here and here to here using the knowledge on your ratios of what? Of triangles, right? So we'll start. To get the distance of this point, x, let's call here to be x from here to here, and also distance from this point from here to here to be what? Let's say it should be z. Let's call it that way, right? So we'll be using ratios of angles in order to achieve that height. Now, if I bring out this triangle here, if I bring it out this way, let me bring that out. I've brought out this true angle here, this true triangle here, this triangle here. So the distance from here to here is 90 degree. Distance from here to here is given to be 150 degree, right? We know them from this point to this point. Now the mean torque is somewhere around here, right? That's my T mean, and that means that from this point straight down to this point, just like you can see in the diagram, from here to here is given to be 1080, right? and the total length of that line from here to here is given as what? 1620. Is that taken? So if from here to here is 1080 and from here to here is 1620. So from here to here is the x we are looking for, which is this x. Please don't forget is our shaded portion here. We are just replicating this diagram that we have here, right? So from here to there, we are going to be having this, if you subtract 1080 minus 1620, we'll be having what? 540. So distance from here to this point is given as what? 540. So if you use your knowledge in ratios of angles here, we'll discover that the base of the smaller triangle x divided by the base of the bigger triangle y, and that is 90, right? So you need to multiply 90 is in degree, multiply by what? Pi over 180 for you to be in a safer side, for you to convert it to what? To radian, equals to the height of the smaller triangle, 540, all over the height of the bigger triangle, which is what? 1620. Is that taken? Now if you do the needful here, converting this into radian, which is saying 90 divided by 180, 90 times pi over 180, that will give us 1 point, as in 1.571 approximately. That's what we have in there, right? So we'll have let me put this face, sorry. So we'll now be having x all over what? 1.571, right? Equals to 540 all over what? 1620. If I cross multiply my value of x here, my x here will now give me, if I cross multiply, 540 multiplied by 1.571 all over 1620. So when you do that, you're going to be having your value to be 0.523. So the x value here will now begin as what? 0.523, right? Similarly, we'll do the same thing here. We have the mean torque. I'm talking about this other triangle here now. This particular one, let's come down. We'll consider this also. So my mean torque the same level as this, right? And the height the same. So if I put it this way, here will be my what? My z is still the shaded area. And the height here too, from here to here, is given to be what? 540 also. Are we good now? 540. So we'll do the same thing. We'll say that the base of the smaller triangle z all over the base of the bigger one, 150. Because in degree you convert it to radian, pi over what? 180, equals to the height of the height of the smaller triangle, which is what? 540, divided by the height of the bigger triangle, which is the same height as this, 1620. So at the long run, my z divided by, if you multiply 150 pi divided by 180, we're going to be having 2.617 or 618 equals to 540 all over 1620. Now from there, if I can multiply, the z here will now give us 540 multiplied by 2.618 all over 1620. So the z value here will now be given as 0.873. 0.873, right? That is the value of the z that we have here. So it means that if I now come to this point here, we'll now calculate the area of shaded portion here, which is seen here as your BE. So I'll say that the area of the shaded portion will now give us the fluctuation of energy is equal to fluctuation of energy, which is equals to what is the area of this of the trapezium, right? So the area of the trapezium here will give me half into brackets the entire base, the addition of what? The entire base here, which is x plus distance from here to here plus z. What is the value of x? X is given to be 0.523. So we have 0.523 plus distance from here to here, which is given as what? 100 and what? 120. And if you convert 120 into radian, you're going to be having, or for a better understanding, 210 times 90 is 120. But because it's in degree, you multiply by what? Pi over what? 180, right? Plus distance from here to here is z, and z is given to be 0.873. So we have 0.873. And the reason why I'm not converting this to radian because it's already in radian. We already did that at this point here. You can see that. So we move forward plus the distance of the entire height here, the length here, from here to this point. And we know that from here to here is the same thing as saying from here to here, and it's still what? 120. So I'll put it 120 multiplied by pi over 180, right? So multiplied by the height. So what is the height? Because we are using this saying that the area of a trapezium is half a plus b multiplied by height. So the entire a is the entire distance here, while the b is the entire distance here. Is that okay now? What I'm using is the area of a trapezium is what? 1 over 2 into bracket a plus b multiplied by what? The height. The a is the addition of the entire length here plus the b is the addition of what is the entire height here, right? I will know from here to here is equal to from here to here. That's what we just applied here. So multiply by the height. What is the height? Height is from here to here. That is 1620 minus 1080, and that is what? That is given as a 540, right? So 540. So we'll now move forward. This will now give us, if you do all the work here, once you add everything you have inside of here, right? Or let me just move forward. So I'll be having 1 all over 2 into bracket 0.523 plus 120 pi over 180 will give us 2.094. So we have 2.094 plus 0.873 plus 2.094, right? Everything multiplied by 540. Is that okay now? Now when you now add everything here, this will now leave us with, this will now be equals to 1 all over 2 into bracket. That will give us 0.523 plus 2.094 plus 0.873 plus 2.094. That is going to give us 5.584 into brackets. We have 540. So when you multiply this, you do the needful. Multiply this by this, 5.584 times 540 is going to give us 1 all over 2 into brackets, what? 3000 2015 point what? 36, right? And when you do the needful divided by 2, you're going to be having 1, right? 507.68 Newton meter, and that will be our what? The BE, fluctuation of what? Of energy. Is that okay now? Now I've gotten it now. Now we'll now substitute BE equals to 1507.68 Newton meter, comma, fluctuation of speed given as 0.02, right? And angular velocity, which is giving us we have this to be, let's see, this is my angular velocity, 439.82 439.82 rad per seconds. Is that taken? So we'll substitute all this into equation 1. And where's equation 1? Equation 1 is this here, right? So that will give us our moment of inertia. So we'll say that moment of inertia of what? Inertia will now give us I equals to what? BE, friction of energy, all over what? Friction of speed times angular velocity squared. The good news is we have the value of all. So we'll move forward. So from here, this will now give us the BE is what we got here, which is what? 1507.68 all over the alpha here is what we got to be what? 0.02, which is already what we wrote here, multiplied by the omega, that is the angular velocity, and that will be 439.82, and there's a square there, or square. You can see that. And this will now give us to be, when you multiply everything you have there, right? So you'll now be having the BE we have here is 1507.68 all over, when you multiply 0.02 times 439.82 square, you're going to be having 3868.88, right? So we now see that the moment of inertia I will now be equals to 0.3897 kilogram meter square, right? So we successfully calculated for this. Now the next thing we are told is to calculate for the mass. Now calculating for mass, calculating for what? For mass. We recall that the moment of inertia I is equals to the mass times the diameter square all over what? All over 8, because diameter is given, right? So we know very well that the I is all calculated for here, which is giving us 0.3897 equals to the mass is not given, multiplied by the diameter here given to be 0.4, but there's a square there, all over what? 8. Now if I should cross multiply, this will come here. I am going to be having 0.3897 multiplied by 8 is equals to the mass multiplied by 0.4 square is 0.16, and my mass here now will now give us 0. If you multiply 0.3897 times 8, we'll be having 3.1176. We're having 3, write this way, 3.1176, right? So if I have that divided by what? 0.16. So the mass here now will now be giving us we divide, our mass will give us 19.485 kilogram. So we have successfully calculated for the moment of inertia and also for the mass. So if you have found this video helpful, please don't forget to subscribe, like, comment, and share the video. Thanks for watching.